Hey everyone, welcome back to MLWorks. In this video, we'll learn how to build a document QA with Ollama and Docling. So we know that Ollama is an open source framework for managing LLMs and Docling is used for parsing documents. So with the help of these two packages, we'll be building our document QA. So there are 6 steps to it. First is setting up the environment and then importing the packages. And then we'll be mapping our document format to specific input format and then convert our PDF to markdown and set up the Q&A chain and invoke the Q&A chain. So to set up environment, first you have to install Ollama, and once that is done, then you can pull the models like Granite 3.1 and Nomic embed text for generating the embeddings. And then we'll be installing other packages like LangChain, Docling, and PDF Miner to pre-process the documents and how to show the results finally. So let's get started with import packages, where we import packages related to Python, and then we import packages related to Docling for document management. And once that is done, we import packages related to LangChain for managing LLM or managing the embedding, and then storing the vector embeddings in FIAS, and how to use buffer memory and retrieval chain. So we'll be using all these for setting up our document QA. So let me run this. Now, once we have imported the packages, what we do is we create a function for get document format. So Docling can handle a lot of formats, different formats. So for our case, we'll be using PDF as the input and then convert that into Markdown. So what we do is first we'll be importing the file and understand its corresponding format, whether it is a PDF, docx, doc, PPT or HTML, and fetch it the corresponding input format that needs to be used for formatting. So we'll be creating this dictionary called format map, and whatever the input file you pass in, okay, if it includes any of these format, then corresponding input format dot format will be picked up. So this will return finally that specific format, which is any of these format. So let me run this. Now, once you understand the format, and what we do is we convert that format to Markdown. So here we'll be converting our PDF into Markdown. First, we take the absolute path of the file, which is this one doxed path, and store it into input path. And then what we do is we create temp file.temp directory as temp directory. This is you are trying to create a temporary file inside your temporary directory. And then we copy the contents of this specific file that we take and pass it to the new temporary input file. Okay, once that is done, what we do is we configure the pipeline for modifying or processing the PDF. So what we do is we use PDF pipeline option, and we don't want to do OCR extraction, so we keep that as false. And from the PDF we want to able to extract the table, so we set it as true. Once that is done, we initialize our converter, which will convert your input format, which is the PDF, into Markdown. So first we initialize the converter, where we have document converter, and if I go back here, if you want to see where it is coming from, document converter, so I guess it will be coming from here, which is Docling, which is the document parsing library. So you have document converter. From here we'll be taking document converter and we are initializing it. And the allowed formats are PDF, docx, HTML, PPT, and format options or how you want to format them. So it is mentioned here. For PDF, we have setting this pipeline option and simple pipeline. This is part of the package of Docling. If you see here, simple pipeline. So it is taken from here and we are setting it as pipeline class. Converter is initialized. What we do is we take the temporary input file, which is getting created while we are executing this file, while we are running this specific program. Okay, it will take the temporary file and convert it. If the results is not expected, it will throw an error, value error. Otherwise, we can export down the results to markdown, and then we'll be storing that into a specific path. So here the path is same as the input path. So based on that input path, there will also find another file called as underscore converted.markdown. Finally, what we do is we finally write down the file here with the help of fp.write and md. So this will give you finally the file, the converted markdown file path, which will be sent as the output. So let me run this here. Yeah, this is just a function. Okay, this is not getting executed right now. So now let us set up Q&A chain. Now, as part of this function, we take multiple parameters. First is the markdown path, which we created in the previous step, and the model name, which is the embedding model, which is this one, and then Granite 3.1 MOE, this is the model name LLM, and we take those as parameters. And what we do is then we kind of take the markdown file, load them, and try to process it. And the processing step is text splitter. We cannot, since a model cannot handle the whole document in one shot, we have to transform it into chunks. So what we do is we create a chunk size of 1000 and overlapping chunk of 200. So consider there are two chunks. There will be chunk 1 and chunk 2. Consider the chunk 1 contains 1000 characters and chunk 2 has 1000 characters. There will be 200 characters that is getting overlapped in chunk 1 and chunk 2. And then we have text splitter, where we perform this recursive chunking on top of the document. And once that is done, what we do is we use the embedding model, which we got from the Ollama, and then we generate the embeddings for those chunks, and then that will be passed as a vector embeddings inside the FAS DB or FAS vector store. And then we initialize our language model, which is Granite 3.1, and where we pass in the model name, and then we have the temperature as 0. So we'll talk about the temperature also as part of document QA later. So we are setting up the conversation memory here with the help of conversation buffer memory, which will take in the memory key as chat history and the output as answer, return messages as true, and this is just the setup part. And then what we do is for the retrieval, what we do is we set up conversational retrieval chain from LLM. So LLM is passed here, and we have the vector store which got created in the previous step here, vector store, which is the FAS vector store. We have to use that vector store as a retriever. So we get the top 10 from that vector store and make use of the memory also if required, and then return the source document. So this is our the QA chain, and this will return the QA chain. The function will return the QA chain. So let me run this also. Now, as part of this function, ask question, what we do is whatever the questions that we want to send to the this QA chain, okay, we can be sending through this specific function, which is ask question, and this will iteratively go ahead and ask those questions and invoke the QA chain. And whatever the results that comes, we use the specific display markdown to showcase those results. Now we are done with all the steps that are required to build the QA, document QA. So what we'll do is we'll now test out the sample. So first is the document path, and we are using something called the system design playbook as document which contains concepts related to system design. So we'll be using that PDF, and what we do is first step is to get the document format, and once we get the document format, we see if document format is present. So if it is a valid document format like PDF, docu, docx and HTML, then we'll be getting inside this if loop. Otherwise, we'll be sending an error like unsupported document format. So once we get the valid document format, then we convert the document into markdown, which will be creating a temporary file. And then what we do is we create a markdown file as well. Okay. Once we get that markdown file path here, finally, then we send it to the setup QA chain. So this will trigger the QA chain, and then what we do is we ask the set of questions about the document. What is the main topic of the document? What are the key points discussed? Can you summarize the conclusion? So we iterate through these questions and we call the QA chain along with the question. So this will, what it will do is it will keep calling the QA chain here and keep asking the question iteratively here. It will keep iteratively calling this particular function, ask question. And finally, it will generate a response, which is we'll be able to view it using this specific display markdown. So let me run this. So detect formats. So the format was PDF and going to convert the document batch, initializing the pipeline, which is standard pipeline with options hash. The accelerator that we are using is CUDA 0. Since I have a GPU, it is using that specific GPU. And it is processing the document here, and then it is finished converting the document to markdown. So once it is converted, it is saving it as a markdown file, and then this markdown file, which is system design underscore converted.markdown, it is sent to that specific QA chain, and corresponding question is asked. So the question was, what is the main topic of this document? Okay, if you see, right, these are the three questions that we asked. Now it will answer all these three questions. So what is the main topic of this document? The main topic of this document is system design, focusing on various aspects such as secure password storage, micro frontend, AWS S3 features, JW usage. So everything related to system design and some of the examples like about how Figma uses system design so these are the different main topics results. Now, what is the key points discussed? So it talks about all the key points here, and then it talks about the next. Can you summarize the conclusion? It will give a summarization of all the results that we see. Now, in the next PDF, what we do is we ask about mlinterview.pdf, which is this specific file where we have a bunch of questions related to LLMs. So concept of LLM and temperature, concept of temperature in LLM. So here also what we do is first step is to get the document path and then send it to get document format. This will tell you whether it is a PDF file or HTML. And if it is any of the valid format, then it will go ahead inside this if loop and convert the document into markdown, and it will set up a QA chain. Then we can iteratively ask the question and it will generate the response based on this PDF. Okay, now the question is, what is the concept of temperature in LLM? So let me run this. It is going through the same process. It is trying to process the document, convert it into markdown, storing them as a markdown file, and then going iteratively asking these questions. So first question was, what is the concept of temperature in LLM? So temperature in LLM refers to a hyperparameter that controls the randomness of text generation by adjusting the probability distribution over possible text tokens. If you see here, this is the question. That we asked, and this is the document it is reading from. Temperature is a hyperparameter that controls the randomness of text generation by adjusting the probability distribution over the possible next tokens. Taking that specific document's result and sharing it here. It is able to understand the specific question and it is able to fetch those exact results from that specific document also. So we are at the end of the video where we have built a document QA where the model is able to go and fetch the exact results from the document based on the kind of question you ask, and it can take in a different format of files and turn them into markdown. For example, if you have any other file instead of PDF, if you have HTML or maybe a PPT file, then it can take that, it will read that content, turn it into markdown file, and then you will be able to turn them into a kind of a rack kind of a system where you will be taking the content, storing into FIASDB, and whatever the input query you have, it will try to answer them based on that understanding of that query. So with that, I'll be concluding this video. Thank you for watching.